All right, welcome, colleagues. We're looking at these questions here in economics. So we can first start with this one here. Briefly elaborate the salient differences between normative and positive economic statements. So, colleagues, a normative statement is something that is opinion based. Okay, it's just an opinion, it's not backed by any facts or any evidence. Okay. Then a positive statement is something that is backed by facts and evidence. So, colleagues, can you give me some of the examples you wrote down of a normative statement and a positive statement? Mm, yes. So what did we say in that? All of us did that question there. Okay. So I want to hear what it's okay if you wrote something wrong or correct. Remember, this is just learning here. So, Mr. Peter, can you give us an example of a normative statement, one which isn't backed by fact, and a positive statement? You can say, for example, let's say the inflation rate of Zambia is 3%. That is positive because you can check, there's data out there that you can check. Okay. You can, that's an example of one. You can say the unemployment level in Zambia is 4% or 10%. That is something backed by facts. Mhm. A normative statement can be like healthcare should be free for everyone. That will make it a better nation. That is an opinion. Okay. It will be hard to get facts on that. Mhm. Okay, I'll let you research, all right? But just remember, normative is based on opinion. It's opinionated. It's what you feel ought to be done, okay? The government should increase salaries for everybody so that we can live better in this country. You know, such statements, opinion based, and then positive statements, then they are fact based. There's actual evidence there, and you can also get the data about that. Okay. Okay. We've got question B here. A consumer has the following utility function for the consumption of pork and beef, where U PB equals P A to the power alpha, B to the power beta, where P is the quantity of pork and B is the quantity of beef. Given also that the prices of beef and pork are PP and PB respectively. So, colleagues, this topic is also still on the consumer theory. When you hear the word utility, it means satisfaction. When you hear the word marginal utility, that is additional satisfaction. Okay? Utility is just satisfaction. Marginal utility, additional satisfaction. So that function that has been given to us, it's a utility function which just gives us the satisfaction a person gets from consuming pork and beef. Okay, this U in brackets P and B, this is a utility function, all right? And it's just measuring our satisfaction that we get when we consume pork and beef. So here in this question, it's P alpha B beta. All right, where P is the units of pork, B is the units of beef. Okay. So with this question, I'm going to illustrate it with numbers so that we get the whole concept. Okay. Because when we're just using signs, we're not going to really understand what's happening here. Okay. We're not really going to get the full picture here. Okay. So let's say this utility function, we're going to make it like this. U equals P to the power 0.5 and B is the power 0.5. Okay. And we're going to say, okay, the price of beef, PB, is going to be 40 kwacha. And PP, the price of pork, 20 kwacha. All right. And let's say this person has an income of 200 kwacha. Okay. They've got a 200 kwacha. And here, basically, what we're just trying to find out is how many units of pork and beef can this person get so that they get the maximum satisfaction with their 200 kwacha. Okay, we want to find out how many units of pork and beef this customer in particular has to get in order to get the maximum satisfaction. Okay, so the first part of this question here is said, find an expression for the marginal utilities derived from pork and beef. Okay. So basically, to get the marginal utilities, we need to derive this utility function. So colleagues, remember the calculus we were doing? The calculus is back here. Okay. So to get the marginal utilities, we're going to say the marginal utility for pork, MUP, we what it means is we're going to partially derive our utility function with respect to P. So all that is telling us is that when we're deriving this function, P is the variable that we are focusing on. Okay. Only P is the variable that we're focusing on. B, you're going to ignore it. Okay. So if we derive this function here, remember differentiation where you multiply the exponent by the coefficient. 0.5 times 1, that gives us 0.5. Then you subtract 1 from this 0.5. 0.5 minus 1, that is negative 0.5. Then B 0.5. Okay, so this is the marginal utility for pork. Any questions? Mr. Peter, Madam Joyce, Madam Wansa, Mr. Who's joined in? Any questions? Mm-hmm. No, they're not in the question. I want you to see this with numbers. Because if we do it, the question, the way it was for the question when you derive, it's going to be like this. It's going to be alpha p the power alpha minus 1 b to the power beta. Okay. Now, if I do it like this at the end of the class, ah, yeah, so it's better we're seeing numbers here. Hmm. Okay. Yes. So, colleagues, any question? Just remember here the key thing, okay, why everything is being done like this. We just want to find out this person, when they go to buy pork and beef with their 200 kwacha budget, okay, we want them to get the combination of pork and beef that will make them the most happy. Okay. So let's get the marginal utility for beef. So let's try to differentiate. Let's get the marginal utility for beef. Use this utility function here, which I've made. Okay. This one, use this one here to derive. For those who have joined, we are looking at the question, the economics test. Yeah, and I've just put figures here so that we understand the concepts better. Okay. So has anyone derived? Okay. On the B. Yes, on the B. Mm. Focus with the one with numbers first, then we'll put the one with symbols. Okay. Okay, okay. Okay, the one with symbols are here. Beta. Beta. Yes, beta. Yes. You bring the beta in front so that you make your answer look nice, okay? Mhm. Your answer must look nice to whoever is marking so that they're even happy. Okay. So- okay, that's nice. That was nice. It's good to hear that. Yeah. Yeah. So now when we use numbers here, yes, 0.5p to the power zero point 0.5, b to the power negative zero point 0.5. Colleagues, are we all okay with that? Y- Put it in the front of everything. Okay. Yes, these two P and B are married. Okay. So you just put it in front of everything. Okay. Mm. You will never see it written like this. Okay. Yes, yes, yes. Okay. Colleagues, are we all okay with what has happened here? Any questions? Hello? I thought my network finished. Are we all okay with this? Everyone is quiet. Mr. Fumbeshi, are you okay with this tabulation here? Madam Mwansa? Oh, okay, okay. So we're looking at this question here. Okay. So in this question here, I've added some numbers so that we get the concept, we get the proper concept. Okay. Yes. So here we're doing part one where we say find the expression for the marginal what's this, utilities derived from pork and beef. Okay. Yes, so I was asking, are there any questions here? Okay. Now, this is not part of the question, but what I'm explaining is going to help us understand these two for part three and part four. This equi-marginal utility and the tangent condition for utility maximization. Okay. These two terms, okay, here they're just talking about the consumer getting the maximum satisfaction with a certain combination of pork and beef. Okay, they're both saying the same things, but they can be derived differently. Okay, we'll come to part two after I'm done with everything here, which is the law of diminishing marginal utility. Okay, or maybe let me even just say it now so that we get over it. Colleagues, the law of diminishing marginal utility says the more you consume a good, eventually the additional satisfaction is going to reduce. Okay, the more you consume a good, eventually the additional satisfaction is going to reduce. Okay, I've also got an example prepared to illustrate this law so that we see it in action. But that's the law of diminishing marginal utility. Okay, the more you consume more of one good, eventually the additional satisfaction starts to drop. Basically, just saying too much of one thing, eventually you get bored of it or tired of it. You start getting tired of it. Okay. Yes. So, colleagues, there's what we call the marginal rate of transformation, MRS. Basically, this is the rate at which you can trade the pork and beef, maintaining the same satisfaction. Okay. The marginal rate of substitution, let's get papers down so that we write this so that we don't forget. Marginal rate of substitution is the rate at which you can trade one good for another, maintaining the same satisfaction. Okay. So this marginal rate of substitution here, in our case here, is the same as saying mu over p, MUP, marginal utility of pork, over marginal utility of beef. Okay. That's how you get the marginal rate of substitution. Okay. So here, in this case, marginal utility for pork is 0.5 p to the power negative 0.5 over 0.5 p to the power 0.5 power negative 0.5. Colleagues, can anyone simplify this one for us? Because in the exam, expect to see a numerical question. And if they ask you for the marginal rate of substitution, you should know to do this. Okay. Can someone simplify? Try to simplify it. Let me see what you get when you simplify it. Excuse me. Has anybody tried to simplify it before I simplify it? Okay, these 0.5s will cancel each other out. If you remember laws of indices, so here it's like the p to the power negative 0.5, since we're dividing, okay, minus 0.5. Okay, then here we have b to the power 0.5 minus negative 0.5. This becomes p to the power negative 1, 0.5 minus 0.5 negative 1, b to the power 0.5 minus negative 0.5, negative and negative make positive, b to the power 1. So again, laws of indices, when you have a negative power, it goes down, b over p. Any questions on how we've done these tabulations? Okay, so I'm going to show you how we are going, because this is going to help us determine the optimal combination of pork and beef that is going to make us satisfied. Okay, that is going to help us get that. All right. Yes. So if in case you ask get the marginal rate of substitution, this is what you do. You divide both marginal utilities. Okay. Mm, mhm. I'm recording. Yeah. So this, let's hold it because we're going to use it later. Okay. Part 3 of the question says state and provide an expression for equi marginal utility for a consumer. So equi marginal utility, so in our case is this. So what this represents, this one, it's the additional satisfaction per one kwacha spent on pork. Okay? MUP over P is just the additional satisfaction per one kwacha you spend on pork. Okay? MUB over PB is the additional satisfaction per one kwacha you spend on beef. Okay, additional satisfaction per one kwacha that you spend on beef. So when the additional satisfaction of the per kwacha you spend on pork equals the additional satisfaction per one kwacha spent on beef, then this consumer has got the best bundle that will make them the most satisfied. That's what Equi Marginal utility say. When the additional satisfaction per one kwacha of pork equals the additional satisfaction per one kwacha of beef, then the consumer has got the optimal bundle or the best combination of pork and beef that makes them happy. All right. This is what the equimarginal utilities say. So we are going to find this bundle, this combination of pork and beef, that's going to make this consumer happy. That's why I put numbers there. Okay. But this is the, when they say equimarginal utility, it's just when the additional satisfaction for one good equals the additional satisfaction per one kwacha of the other good. When they're equal, you get the best combination of the goods, or you get the best bundle of the goods. Okay. Any questions? The tangent condition for utility maximization is this one here. Okay, the tangent condition for utility maximization. When we say tangent, it just means when the slope of the indifference curve and the slope of the budget constraint line are the same, then the consumer has got the best bundle. Okay. This one on the left-hand side, this is our marginal rate of substitution, MRAC. On the right-hand side, this is the slope of the budget constraint line. Okay, the slope of the budget constraint line. So the slope of the budget constraint line and the marginal rate of substitution, which is also the slope of the indifference curve, when they are equal, then the consumer has got the best combination of goods that gives them the most satisfaction. Okay, that's the tangent condition. So we're going to bring back those numbers so we can find this combination of pork and beef for these two conditions here. These conditions are just basically saying the same thing. We just talk about the best bundle. When I say bundle, it's just a combination of pork and beef here. The best bundle, or the bundle that's going to give you the most satisfaction. Yeah, the bundle that will give you the most satisfaction. Okay. So if we come back to what we were looking at earlier on here, we've already got our marginal rate of substitution. It's B over P. Okay. Now we need to get our slope. Okay. So that's why I added this information here. All right. The price of beef, 40 kwacha. The price of pork, 20 kwacha. The income, 200 kwacha. So you have a 200 kwacha and you want to say how much pork and beef can I buy so that I get the most satisfaction, the most out of the most out of your money. Okay. That's even what this, when we say this additional satisfaction per one kwacha, it's the most, basically what we're just saying is you're getting the best out of the money that you're using. Okay. The best that you can get out of the money you're using. So we want to get our slope so that once we get our slope and we use this tangent condition, we can be able to get the best combination of pork and beef. Okay. So we need also to form our budget constraint line. Okay. So remember, budget constraint line is in this format: M equals P, P. And I'll put a QP so that it represents the quantity of P. So this is the price of pork times the quantity of pork plus the price of beef times the quantity of beef. All right. So if we substitute, M is income, so if we substitute M, it's going to be 200 here. Price of pork, 20. Since we're using variables, let me write it like this. Okay, QP, I represent it just by P here. And QB, I represent it by B. Because there will be some substitutions involved and I'll need to substitute. So this P is just, this green P is quantity of pork. This green B is quantity of beef. So this is 20P plus 40B. This is our budget constraint equation. We want to get the slope. Okay. So the slope is this negative P over PB. Okay. Why is a negative slope? Because the line is downward sloping. Even for this marginal rate of substitution, I forgot to put, it's also a negative slope also. Okay, because the difference curve is coming like this, and then the slopes of the lines are downward. Okay, but once when we reach this point here, these two negatives will cross each other out. They'll cross each other out. But here for now, our slope is going to be price of pork, 20, over price of beef, 40. Okay. 20 divided by 40, what do we get? Twenty divided by 40, what do we get? I think that's negative 0.5. 0.5. So what this slope is telling us, how it says to get 1 unit of beef, you need to give up zero point 0.5 units of pork. You give up zero point 0.5 units of pork. That's what the slope is telling us. Okay. So now, when we come back here to this tangent condition for utility maximization, we can be able now to find out how much pork this person needs to get and how much beef they need to get so that they get the most satisfaction out of their money. Okay. So if you remember, our marginal rate of substitution was B over P. Our slope of our budget constraint line was 20 over 40. As I said, these negative signs, they cross each other out. So when you're doing this tangent condition, no need to put the negative signs there. Okay. Yes. So let's cross multiply. 40 times B, that is 40B. P times 20, that is 20P. So we can find the value of P, divide both sides by 20. 40 divided by 20, that is 2P. So this P equals 2B. We're going to take it back into the budget constraint equation so that we can find the number of units of pork and we can also find the number of units of beef. Okay. So our budget constraint equation was 200 equals 20P plus 40B. We found that P equals 2B. So we substitute P with 2B there. So that is 20 brackets 2B. Twenty times 2B, that is 40B. 40B plus 40B, that is 80B. Okay. So 200 divided by 80 to get the value of B, we divide by 200. 200 divided by 80, what do we get? 200 divided by 2.5. Okay. Okay, so for this person to get the most satisfaction, they need to get 2.5 units of beef. And we need to find out how many units of pork can they get. So remember P equals 2B, right? So here P equals 2, where there's B substituted with 2.5. 2 times 2.5, that is 5 units of pork. So For this consumer to get the most satisfaction when they go to this grocery market to buy pork and beef, they need to get 5 units of pork and 2.5 units of beef. And when they get that, they are going to get the most satisfaction. Okay, they would have used up their whole 200 kwacha and they will get the most satisfaction. Okay, which is represented by these two conditions here. Okay, the tangent utility condition and the equimarginal utility. Now, the reason why I haven't chosen the equimarginal utility is because we need to first get our total utilities, get our marginal utilities. So it's a longer process. Okay, it's a longer process. But eventually, with both processes, okay, you're going to find that for this consumer to get the most satisfaction, they need to get 2.5 units of beef and 5 units of pork. And the tangent utility condition, as I said, will be represented like this. Okay, you have beef on your y-axis and you have pork on your x-axis. When you draw your budget constraint line, so for us to make our budget constraint line, you just get the intercepts, okay, where the line cuts the b-axis and the p-axis. Or in simple terms, for example, if we say we want to get the p-intercept, we're just saying that with this 200 kwacha, if this consumer just buys pork only, how much pork can they buy? Okay. If this person spends the whole 200 kwacha on buying pork, so to get the intercept, it's just your income over the price of pork. Okay. So if this person spends his whole 200 kwacha on pork, 200 divided by 20, that is 5, or that's 10 units of pork. All right. So here on the budget constraint line, you put 10 units here. And if you want to find out if this person spends the whole 200 kwacha on beef, how much beef can they buy? It's just the income divided by the price of beef. 200 divided by 40, that is 5. Okay, so this is our budget constraint line here. Then we have our indifference curve. An indifference curve just shows the combination of pork and beans while maintaining the same satisfaction. Budget line, combination of pork and beef while maintaining constant budget. So you draw an indifference curve here like this. So where the indifference curve and the budget line touch each other, where they are tangent to each other, or where their slopes are equal, okay, which is this one here, mu p over mu b equals pp and over pb. When the slopes of the budget constraint line and the indifference curve are equal, that's where you get the optimal band, the bundle that will make you the most satisfied. So this is 2.5 here for beef, and this is 5 units for pork. Okay. So just a recap. Equimarginal utility and the tangent condition for band optimization. Both of them are just talking about your optimal bundle that will give you the most satisfaction. Okay, with equimarginal utility, you're just saying the additional satisfaction for every one kwacha spent on pork should equal the additional satisfaction for every one kwacha spent on beef. In the tangent condition, you're just saying the slope of the indifference curve should equal to the slope of the budget constraint line. And the slope of the indifference curve is the marginal rate of substitution, which is telling us how we can trade two goods whilst we maintain the same satisfaction. The slope of the budget line is also telling us how we can trade the two goods again, but this time maintaining the same budget or the same income. Okay. MRS, same satisfaction, slope of the budget line, same budget amount, but they're both talking just about how you can trade one good for another. So, colleagues, now this is the time for questions. I think maybe I explained too much. So, where you got lost, please, you can take me back because after this, we need to derive the demand curve for this person. Okay. What I was showing you yesterday, that graph which I showed yesterday, we're going to use that graph with numbers here so that we also derive. So, questions first. Mr. Yes, sir. And then for the indifference curve, I just drew it. I just drew it like that. I was just trying to illustrate the point. But the indifference curve, you can get it by substituting values in this. Where is this? This utility function. You just put in values. That's if P equals this and B equals this amount. What's the utility there? You just start substituting. In the budget line, you get it from this budget constraint equation. Yes, the indifference curve, I never just started putting the values and everything because with the indifference curve, there are no intercepts just to connect the lines. Have you seen? So we need to make a table. We start plotting, so it might take time also again. Okay, it will take time plotting this indifference curve. But for the slope, for this budget line, it's for you to draw it. Just get the intercepts. So once you've got the intercepts, just connect them, and then you have drawn your budget constraint line. Yes, but the okay. But just remember, when the slope of the budget constraint line and the slope of the indifference curve are the same, tangent utility maximization condition, it means that combination of those goods will give you the best satisfaction. Okay. So in this case, for this person here, when they buy five, what did we say was the best combination? When they buy five pork and 2.5 beef, okay. Colleagues, why do you think I'm not rounding off here? Out of curiosity, why don't you think I'm rounding off? Because if you round off this to 3, and when you substitute both of these values back into the budget constraint equation, it means you'll go over budget. Okay, because when P is 2.5, when B is 2.5 and P is 5, it means you've used the whole 200 kwacha. Okay. Okay, colleagues. So we do the deriving tomorrow for the demand curve. Okay. So today, what I just need you to get from today's lesson: equi marginal utility when the additional satisfaction for one good, additional satisfaction per kwacha or per dollar for one good equals the additional satisfaction per kwacha or per dollar for another good. Then that combination of goods gives you the most satisfaction. Okay. Or when the slope of the indifference curve equals the slope of the budget constraint line, that combination gives you the most satisfaction. Okay. So part 3, the equimarginal utility, this is what you are supposed to put, and also substitute these values there. And also in tangent condition, you are supposed to put this.